the coordinator of the aligned project, Professor Massimo Pizzol, will tell about the aligned LCA methodologies and how you can participate in making these better and giving us your feedback, which we really appreciate that. After that, we will have a deep dive by Dr. Daniel Abo of INSA Toulouse. He will tell about the time dependency of GHG emissions on the LCA impact part. And after that, we hope to have an interesting discussion on the time dependency first, and then the general methodologies. And yeah, given the amount of people who are here, we have decided to gather your opinion via the Teams polls option. And so we hope that that will give some special energy to the workshop, and we look forward to that part. I already saw a question via the chat, which is certainly open for that. The recording will certainly be made available. Absolutely, yes. So that will be there. Rest me to say, all of you have a very nice workshop. We hope you enjoy this. And I would like to give the word to Massimo to start his presentation. So thank you all, and a pleasant workshop.
Hello, everybody, and just a second, I'm turning on my presentation here and sharing my screen. Here we go. So I hope you can see your presentation and you can also hear me. I'm Massimo Pizzol. I'm coordinating the Align project from Aalborg University side. And today I'm going to give you a sort of overview of the scientific methods that have been collected and refined during the Align project, and that are part of our what we call the scientific framework that has been developed during in the first work package of a project. So what are the scientific methods in Align, first of all? Before we go into that, I would like to, I have presented this slide before, maybe you have seen it in previous workshops in our project, but just to give an idea of what the Align project is doing. So we want to bridge between the theory and methods that are existing in the scientific literature and in research, and the practice of LCA practitioners or practitioners that have to assess the environmental performance of bio-based products in industry, consultancy, and and policy. And our project is about selecting the most scientific methods for a series of to solve a series of problems, and then facilitate their use in practice. So the scientific framework is a framework for the LCA of bio-based products, includes a mix of approaches, methods, and tools. It is also an open framework, so all the tools are openly available, and then has been also tested in the case studies of a project, and is supposed to be applicable across 5 sectors, which are the sectors that the project targets, pulp and paper, textiles, construction, woodworking, and oh my god, pulp and paper, textiles, construction, woodworking, and I missed the last one. Chemical sector. Thank you so much. I should have written that. Right, so the way we have structured this framework is to follow the ISO phases. So the different steps in a way that you have to use for, you have to go through to do an LCA. So we have methods that cover the life cycle inventory stage. Particularly, we have methods here for the dynamic perspective assessment. And then also the LCA and the goal and scope. We have methods for identifying market constraints and for time and space dependent carbon accounting. Then we have methods for the impact assessment stage. You will hear more about them today. We have characterization factors for dynamic assessment of climate change. And we have also methods for interpretation phase, particularly, we have methods for uncertainty and sensitivity analysis and for socioeconomic assessment, all of them for application in bio-based sectors. Everything has been collected, and this has been presented before, maybe you've seen that already, has been collected in what we call our deliverable 1.2. It is is a series of documents with deliverable that includes guidelines, tutorials, routines, algorithms, templates, data sets, models, spreadsheets, and calculators, code, and notebook, and all are available open access in a series of project repositories. You see here the link to the Zenodo repository, Zenodo community page, sorry, where all the repositories are collected together. So here you can click, for example, in one of these repositories and find all the guidelines and materials. What have we done with this framework? So about 1 year ago, we had made a sort of beta version. So we have first released this version of the methods and of the framework. And the plan in the project was to then apply this framework on 5 different case studies. Actually, yeah, it's actually 6 case studies in the different sectors. So at least one per sector. In order to test it basically and see how it works in practice. Then we have also been holding some methodology workshops like today in order to provide information about these methods and also to get feedback from the stakeholders. Then we have also been collecting feedback from the partners via specific interviews after the application of the methods. And then we have also feedback from external users via the specific surveys. Based on all this material and testing, then we plan to have an improved version of a framework after, let's say, the application in practice, after testing. And this would be at the end of the project in September this year. So I'm going to go through each repository that we have a bit quickly because I've been presenting these things in a previous workshop. So if you have been attending me once before, I don't want to repeat the same things. The novelty today is that I will also give a short teaser about what are the improvements that we expect for each method and repository. So we start with the methods for the background lifecycle inventory. Here we have a description of how you can do this. Can you create a prospective version of a background inventory to make the analysis, for example, of emerging technologies. And then we have a set of tutorials for doing it and an example. And these have been divided in different levels of complexity, what we call the tiers. Yeah. And what we plan to improve is that after we have been applying this, we realized that some instructions in the tutorials could have been written in a better way, let's say, and therefore we have been working on improving the tutorials to make them more applicable and more user-friendly. So what you will find in the final version will be more or less the same material, the same recommendations regarding the choice of scenarios and so on, but better tutorials for applying this in practice. Then we have the methods for foreground lifecycle inventory. Here we have a method to model constraints of biomass availability and also document on the screening of the data sources that can be used to calculate a market mix and a comparison of them. And then examples of how to make a model of market mix from Faustat data. Event code for doing that. I could hear somebody, but I hope you can still hear me. And then a data set there. What we will have in the final version is we are not going to revise all this material because turned out it was quite fine the way it was, but we will have also additional data. In particular, we will have a new version for the calculation of a market mix for feedstock in Europe, in particular forest feedstock. forest-based products that we have developed during the project. Then we have also methods for foreground lifecycle inventory. We have a data template. This is a guide that we have been using the project to structure and share inventory data, foreground inventory data, and then various guidelines and templates on how to structure those. And importers to import the data from the template into different software. And here we have been testing a lot this, and we have found several issues. So what you will get is better tutorials for more easy applications, more importers and exporters, where we have also fixed bugs and various errors that were there in the documentation. Although, so the data template as such is going to be the same, but the explanations will be better and the importers will be better. Are better. I mean, we are updating the material as we go. Then we have again methods for foreground lifecycle inventory. We have our dynamic carbon model. Here is a data set of all the biomass types and their characteristics. A model that can calculate carbon flows for forest plantation, and a tutorial for using that. And then also we have data document that shows how we validate the model and the data for that. So in the final version, you will find we have now found, while using the model, some issues. We have improved the model itself, and we also have improved the data set. In particular, we have done more validation, and also we have decided to restrict the data set to the data where we think we have the highest quality and the most consistency, because to put together this data set, we have to put together data from different sources, and we found that some of them were not completely consistent. So we have done a sort of quality check, quality assurance of the whole data. Then we have a methods for life cycle impact assessment. We have a guide on the LCIA of bio-based products for climate change and biodiversity, a tool for dynamic characterization factors, and a tutorial for how to do the assessment. You will hear more about that today. And then also a data set with the characterization factors and tutorials for how to use them. In the final version, we will have an improved version of many of the tutorials. The data are good as they are, but the way they have to be used was not could have been improved. And then we have also changing the tiered recommendations, because we found were a bit too ambitious, the ones we had so far, so it was difficult to apply them. So we have to lower down the level of expectation. Methods for handling uncertainty. So we have a guide on the appraisal of uncertainty. We have different calculators for uncertainty analysis and tutorials. What we have done here is that we have made basically new tutorials. So the content is more or less the same, but we have new notebooks. We have updated to newer versions of software, and we have added some functionalities to make more types of sensitivity analysis, and for doing that to more different type of models. In particular, to do it not only at the level of each single exchange in an inventory, but the level of the parameters of a model. If you have an LCA model that affects multiple exchanges in an inventory. Finally, methods for socioeconomic assessment. We have that's the most sort of a more experimental part of the project. We have a model for techno-economic assessment and a tool, and the same for model for quantification of social indicators, and also a model for stochastic multi-criteria decision analysis and a tool to do that. And basically what we will do here is that we will have an improved description of these models and tools, because it was not sufficiently complete, let's say. What are the next steps in the project now? Our methods are open. As you've seen, I've been showing all these repositories where you find all our materials. People are already downloading them and providing feedback. Thank you to all of those who have done that. And you can still use them, and we would like to hear from you afterwards. There is a link here to form where you can give your feedback if you have been using one of our methods, and you're still in time because we will use all these feedbacks in the revision of the methods towards the final version in September. Another thing is that, as you can see, the methods have been tested on case studies, and we've been collecting the experience of the users, which are mainly the academic partners in the project, but also the industrial partners. So we have gotten the very critical, the useful and constructive perspective and comments from people in both in academia and in the industry that has been using our methods. And we have done it also for a range of cases. So we have the same methods applied in several cases. And by doing that, I think we have done quite extensive testing of these methods and their advantages and limitations. Today, we'll also retrieve additional feedback from the audience, from you. You are our part of our stakeholders, so we are really happy to receive your opinion on our framework and the way it is structured. And then we will do, as I said, a revision of the framework for a final version in September 2025 this year. One thing that has been flagged before in previous workshops and also during the testing is that yeah, we need to make these tools very much applicable as much as possible, more than we think. I mean, ideally, people would like a system where you press a button and you get answers. I don't know if we can get exactly there, but we are getting as close as possible to providing tools that can be applied very, very easily and in a logic understandable way. That was it from my side. I don't have much more on this presentation and this overview. I hope I can. It was complete enough to get an overview of what we are doing here in this project, and I'm very happy to take your questions. Patrick or Rachel, are you there? Yes.
Yes,
are
I think
there.
if people have some questions, they can always post it in the chat. It's also went well during the presentation that people already got some answers. And if you want to put on your microphone, you can raise your hand. And otherwise, I think we thank you for that nice presentation, and we can always discuss later in the interactive part if you think of something, and it can always come up later.
Yeah. Thank you, Massimo, for this.
Thank you.
And I think we can now go directly through to Damien Arbeau of INSA Toulouse. You will talk about the GAG emissions and the dynamic alignment, I believe, dynamic accounting of that. Damien, please go ahead.
Yeah, thank you, Patrick. Thank you, Massimo, for this nice presentation, and you gave me an extra minutes. So, but I try to be as concise as possible, even though, as Massimo mentioned, this task of applying time-dependent climate impact indicators is, well, need to be refined and a bit simplified for a better application. Although what I will show today is related to, well, the first version of the tutorial that you can find on the Zenodo repositories.
Yeah, the sound went away. Damien?
Okay, yeah, I don't know
now
why.
We can hear. Yeah, we can hear you again. Yes, thank you. Sorry.
Thank you. So just to summarize in a single slide where we are. When I press the space bar, actually it changes. So we are here today within the whole Align framework, which aims at, as Massimo said, bridging the gap between theory and methods in scientific literature, but sometimes we're far away from real world situations. So we've in the work package 1 dedicated to the methodological framework, we've been working on this hot topic on how to account for climate change, especially when it comes to biogenic carbon flows and long-term versus short-term emissions. How we worked, the general approach to build this framework is to collect information from a lot of different engaged stakeholders, industrials, scientific experts, but also take a look into the high variety of guidelines and policies. We extracted 4 key challenges around which we build our recommendations. Confronted these challenges and recommendations to the existing standards and guidelines, and then tailored these recommendations into a tiered approach from the least experienced users to the most experienced ones, so that it can also be a useful approach to learn how to deal with climate issues. We can go into this questions a little bit later if you have questions. So when it comes to climate change impact assessment, we set a common base of recommendations upon which, for more tricky questions, we propose a stepwise guidance that I will show you an example just after. And for tasks that are really quite complex and for which the guidelines the standards are not diving into, then we build a tiered approach, and it's especially the case when you want to explore the time dimension of greenhouse gas emissions. The common base might seem a little trivial for experienced LCA practitioners, but we thought it was also good to remind them. As a life cycle assessment is always recommending to implement the cradle to grave approach, and so which means have tools and tutorials to deal especially to the use phase and the end of life, when it's not easy to assess because it's downstream the value chain of an economic activity. We also recommend to report and document separately biogenic carbon flows and non-biogenic carbon flows. This is important to be aligned with most current and future guidelines and reference material. We also noticed that recommend that it might be it's of high importance to compute at least 2 indicators for climate change, because a single indicator does not reflect the complexity of climate change, and especially make the difference between short-term effects and long-term effects. And we think that the climate change impact assessment is going towards that direction, be a bit more exhaustive than a single indicator. Then the -1+1 approach means that we recommend to account for both biogenic carbon uptake by especially during biomass growth, but also biogenic CO2 emissions. And so then we will talk about time effects with the tiered approach in a few minutes. For the end-of-life stage and this stepwise guidance for tricky parts. Well, I won't go into the details of this chart. It's everything is available on the repository. You can look at it later on if you did not already. But the two main questions, yes, concern the how to model or how to account for the end-of-life stage when it's not precisely known, which is the case for most B2B activities. And also, when does it matter, or in which situation should it be interesting to spend time investigating the time effects in climate change impacts? We could see in some case studies that it was not always relevant to go into that level of complexity, but for some other cases, yes, it is. So how to figure out when it is relevant or not? Well, the tier approach is also interesting for this. Our goal is to propose a tier 1 approach that is as simple as possible, so that you can really answer the question, is it important to account for the time dimension in climate change impact, in GHG emissions? And then after it is, the tier 2 is fine-tuning of this time distribution. And then tier 3 with current published framework is how to expand the analysis and the interpretation with more indicators than the global warming potential. Well, of course, you could also always go beyond this and use state-of-the-art in climate science to identify different types of climate effects or the different damages to the various endpoints. You can use dynamic and time-explicit models that are much more powerful, but our goal was to help the practitioners to do the first steps towards that increased level of knowledge and interpretation. Okay, so let's go now to the case study I'm going to use today to illustrate the use of timed GHG indicators. The case study has been related to a thermal insulating material developed by the Kingspan company. I present here a very simplified diagram of the life cycle. And yes, of course, today the insulating board is made of phenolic foam, and this phenolic foam comes from 100% of fossil-based feedstock. And the aim of the study was to identify what are the available technologies and what would be the environmental consequences of switching to bio-based phenol feedstock. So here, the life cycle is composed of, biomass growth, hardwood cultivation and harvest, and then a lot of different processing steps, delivering several co-products, because not all biomass in hardwood is composed of phenol. We cannot convert 100% of biomass into phenol. Only a small fraction can be retrieved, and other biomass fractions are converted to other feedstocks or material. Then the use stage is quite long, of course, for an insulating material. When it's on place, it doesn't move. It's quite a passive stage. And the end of life is also a bit tricky because it occurs far away in the future. So this is typically the case when we don't have primary information for what would be done with these insulating board when they are used and replaced. So we figure out a kind of composite end-of-life scenario composed of most part of the board can be valorized either with mechanical recycling or as a heat supply to a cement factory. These scenarios were built in collaboration with our industrial partner. And a small fraction also cannot be valorized because it is mortared, and we could also consider that in some cases this and used material goes to the landfill directly. Okay, so let's apply the tier 1 approach now. It is composed of 3 steps. Here I give you the screenshots that I took from the report available in the public repository, so that you can make the connection between the report and this presentation. The first step is to define life cycle phases. So, well, you have in general 4 basic stages: the biomass production, then the manufacture and production of the product, the use and the end of life. And for each phase, you can define a calendar period and set a equivalent year, generally in the middle, and so that you can set start to the year count to explore the time dimension of the life cycle. For each stage, then, well, it's pretty much routine work for life cycle inventory. You compute all the emissions and uptakes of each greenhouse gas. And then after, you can use the calculators and tables available also in the public repository to retrieve the relevant characterization factors for the years that are representing the different phases. So when you apply it to this case study, we have 3 main life cycle phases. I discarded the use phase because it's passive, so there is no emission and no uptake with this product. Yeah, one important detail here is that you can see that the year count for the hardwood cultivation, so the feedstock growth, is actually occurring after the manufacturing product. Why is it so? It's because we are trying to assess the consequences of taking a decision today. What if we go bio-based for phenol production today, where we are going to use existing feedstock? And if we want to do it sustainably, we will plan the regrowth, which will occur in the future and in the quite a long period. So that's why the year count for hardwood cultivation is after the manufacturing stage. Okay, then the next step is to build the inventories and calculate them with your usual software. As presented in the common recommendations, we've separated the fossil and biogenic CO2 and methane flows, and then retrieve the characterization factors for the 2 global warming potentials, 100 and 500 years, with the specific, with the relevant years. And for the comparison, I also put the time invariant characterization factors calculated from by IPCC. And okay, so let's have a look at the results. So in this table, we'll compare for each of the 3 stages the 2 global warming potentials with the time invariant approach and the tier 1 approach. And well, we can see that there are some significant differences in the results in the total life cycle, and which means that, okay, we have the first answer to the question: yes, temporality of GHG flow actually matter. And we can also see that the major difference is found in the forestry phase. So yeah, the next step will be to refine this forestry phase with the temporalized GHG inventory. And to do so, we used the forest management model from the dynamic foreground flows of available in the aligned repositories. We select the relevant wood type, and then it calculates automatically for each compartment and each year the different carbon flows, and in the end we find the annual inventory of CO2 fluxes in the last columns. So that's great. We just have to take these tables and then, of course, do the same distribution for the other life cycle phases, manufacturing and end of life. And then we repeat the calculation to get this table for each life cycles phase. We can see here the comparison between static tier 1 and tier 2 approaches. The differences are not huge between tier 1 and tier 2, which is a good sign because we are just fine-tuning what we found at first step. We can see that the largest differences occur for long-lasting activities, while in the contrary, when we have processes consider occurring only in single year, so what we can call pulse processes, and it's near to present time. It was the reference here was year 1, so the difference is very small, obviously. And on the contrary, in the far future, we can see significant differences between static and tiered approaches, especially for global warming 100. And this is mostly because since the end of life of this product occurs around year 90 or something like this, so it's close to the time horizon. So of course the influence of these faraway emissions is much less important than in the invariant GHG accounting. What's also interesting is that we can plot these results in a timeline. So here you can see the plots for both time invariant global warming potentials. And while we can see the first peak at year 1 is, if you look at the details of the result, we can see that it's mostly due to the fact that we co-produce ethanol, but this ethanol actually would displace the production of ethanol, of sugarcane ethanol, somewhere else, which in turn displays the CO2 uptake by these sugarcane productions. So yeah, it's a good takeaway also to keep in mind what we would displace or replace when we go into bio-based material production. Then we can see that the cumulative climate change effects are decreasing during the tree regrowth, which depicts the carbon uptake by the tree. The end in the far future, we can see that there is some decay also of non-harvested wood that increases the cumulative amount of GHG emissions. And well, here this little bump is due to the end of life stages. So okay, one other comment is that even though we produce something in year 2025, there are GHG emissions, GHG flows for over more than 100 years. So yeah, time actually matters here in this situation. We can also see that when it comes to time invariant characterization factors, both GWPs are pretty similar. This is because, well, most emissions are due to carbon dioxide. The other greenhouse gases are quite negligible. So when we convert only carbon dioxide into carbon dioxide equivalent, then we have, of course, the same result, whatever the time horizon. Okay, now let's compare with the time explicit global warming potential. We can see that the curve, the blue curves are a little bit higher. That's because the far in the future you are, well, the smaller effects you have on the global warming potentials, especially in a 100-year time horizon. That's why the dashed curve is higher than the dotted curve. So we can see also that the two indicators show some significant differences. The two indicators, meaning global warming potentials with the two different time horizons. And that's also because, well, emitting CO2 in today is not the same as emitting it in the future when it comes to short-term impact. Okay, and we can also see in this chart that the cumulative effects overall remain positive. So there is a net emission for the first 30 years. So it's only after 3 decades that we can see that there is a benefit of carbon uptake by biomass growth in this configuration. So it's also important to be kept in mind when we want to use biomass as a leverage to tackle climate change. Sorry, I'm a bit long. I'll try to hurry up a little bit for the takeaways. Yes, so first of all, when we rely on long-term rotation biomass, well, we need to, of course, in parallel, secure strongly sustainable forestry planning because the uptake will occur after the emission. When we compare time-dependent and time-invariant characterization factors, we can see that the closer we are to time horizon, the smaller the effect of these emissions when we use time-dependent characterization factors, and which means that this time-dependent approach is consistent with using a fixed time horizon, and on the contrary, using time-invariant characterization factors is consistent with considering that the effects, whatever the year of the emission, the effect will last for a constant time after the emission. So if we want to have a goal for 2050 or 2100, might make more sense in a way to use the time-dependent characterization factors. Last but not least, to sum up, what we can do with this framework is, well, first use tier 1 as a basic application of time dependency in life cycle assessment, and it's also a good way to learn in the simplest way data organization for this exercise. And it provides a quick answer to, yeah, does it make sense to go into temporalization or not? And then the tier 2 approach, well, it's more a fine-tuning. Now we are experienced with data organization, and to a basic application, we can make it more precise. And it's also nice to enable visual analysis and see that, yes, we can see short-term and long-term consequences of a decision are not exactly the same. Okay, and for next steps, as Massimo said, your feedbacks are most welcome to improve and update the guidelines and tools that you can already find on the repository. I thank you for your attention and be glad to answer your questions.
Thank you very much, Damien, for this quite interesting presentation and also for being perfectly on time, which is really a very nice added benefit to this. Yes, there is, of course, a time and place now for questions, which you can put via the chat, or if you are there, you can also raise your hand. Anybody, any question or comment?
Damien, there was a comment before on one of the slides. Don't remember the number of the slide. Let me just check it. It was a slide number 7.
I didn't even put the number on the slide. So
yeah, it's the one where you have a tiered approach under the outcomes.
That one, yes.
This one, thank you. So there is a question: what is the difference between GWP 100T with a T in parentheses and the normal one?
Yeah, it's just a visual way to mention that these Cartesian factors are time dependent, time matters, as you said in your answer, instead of the static approach that you've been using in the current practice. Okay. And yeah, if I to be extra robust in this slide, I should have put also the parentheses NT in the tier 3 approach, of course. And
Okay.
it's not mentioned here. Yeah.
Thanks. That was where I wasn't a bit unsure, but perfect. I think Ben, you should have answered the question from the audience.
Okay, very good. Yeah, we are now going to the interactive part. And yeah, because this last presentation, this last topic was closest, the latest, we think it is closest in all our collective memory. So we would like to start with a discussion on that part. Rachel, would you care to test whether the poll works?
All right. Then we will see. I will launch the question now. And do you see something popping up in your screen?
Yeah, well,
Yes.
at least I see something popping up.
Yes.
Yeah.
Okay.
Yeah,
Then
the idea here is that you can, you see as a, if everything is right, you see as a question, what do you see as limitations of the methodology? And then it's, of course, the methodology as presented by Damien. And you can answer that and send the answer, and you will see the results at some point also as a pop-up, and I think also in the chat. And the idea is, well, we would like to gather your inputs on this, and we would like to react on that. And of course, any of your reactions is also very valuable here. So are you actually, we are able to select one of these 6 bullet points. So please try it and try to see, do we see any limitations of the methodology? And if you don't see any, then yeah, you can put in other, I would say.
yeah, we can already see people start to respond now.
Oh, very good.
So we have about 19 responses. So thank you all for trying the poll. And we also have one other that used the chat with a question from Marion saying, do you have any hope your recommendations that can be taken into account in future standards? For example, taking into account the temporal effects in the EN 1584, which I think is used in construction.
Yeah. Thank you for the question. A very good question, in fact. So from a project side, we are trying to get our recommendations as far and as widespread as we can to several stakeholders. One of the stakeholders are, of course, standardization bodies and committees. As far as I know, we haven't been able to get into this specific one yet. But that's we keep working on that because it's a bit of a lobby work in a way. We have been though in contact with, for example, the UNEP initiative on biogenic carbon. Damien has been part of that, and we have also been in contact with other standards. So I think some of our recommendations will be for sure taking into account some of the future standards, but I can't say anything specifically on EN 15804.
Yeah, and maybe it's good to add to this that in Aligned, we are not really, it was not our first intention to develop a standard or something. We to develop a method, and which would, of course, be scientifically appropriate and justified, and check whether it works. And standards are indeed then a next step already. So it could be very well that certain elements can be taken into standards. It's beyond us to be very definitive about this. Of course, we try to elaborate and fine-tune our methods and disseminate these results. Yeah.
And there is another question about the how can we estimate the carbon footprint or uptake? These are two different things of a feedstocks if it comes from biorefineries, for example. I mean, not just growing a tree. I'm not sure how to interpret this question, but I'll do my best here. So biorefineries, they can use various feedstocks. In our project, for example, we have two biorefineries. One is using microalgae as feedstock. The other is using wood products or even wood residues. Actually, it's not exactly they are flexible, so they could use a variety of lignocellulose feedstocks. So in all these cases, what we have been doing at least was to calculate the carbon content in these feedstocks, which are bio based or that are products, plants, and use this as an indication of the carbon uptake that is associated with these specific plants or organisms in case of microalgae. And yeah, that's the first approach. Of course, one should be a bit careful because sometimes it could lead to underestimations as well. So not all the carbon that is in a plant corresponds to the CO2 that was uptaken, but there could be more CO2 uptake that is then not in the final product, but has been part of some waste or in the soil or so on.
Yeah, if I may.
Yeah, Damian, you're very welcome to contribute too.
Yes, was one of the tricky question, like with the advent of technologies for carbon capture, air carbon capture, because is it biogenic or not biogenic? Well, that's also a reason why we consider that the -1+1 approach is what matters. It's in the end doesn't really matter if the carbon atom comes from fossil or feedstock or biomass, because CO2 is CO2 and it's the same impact on the climate. And CO2 uptake from the air is also CO2. It's the same chemical. But still, when we in this case study and this biorefinery I studied, we use some also fossil-based chemicals like solvent, and some of them are also reacting with the biomass, with the cellulosic material. So there is a mixture in some of the products of carbon coming from fossil methanol and carbon coming from biogenic feedstock. Then, well, the mass balance needs to be ensured, and where in the end, if we use a -1+1 approach, if we are wrong in the share of CO2 from biogenic and fossil, the result remains the same in general. So that's why also we recommend to at least use the total CO2 emissions for the interpretation, rather than the partly fossil or biogenic. The accounting, splitting biogenic and fossil in the accounting is merely to be consistent with some existing guidelines that do not use this -1+1.
Thank you, Damien. I think there was another question in the chat, but I answered in the chat, so I think we can move on with the next survey.
Okay.
Damian and Massimo, can you also react to this, the answers to question 1? What do you see as limitations of this methodology? The largest answer is.
Yes, sure.
People think it's not compatible with LCA software or databases. What is your view on that?
I think they are quite right. In fact, this is for a lot of LCA software is not very easy, if not impossible, to include a dynamic profile of emissions. So in fact, also in the project, what we had to do was that you use our tools to calculate the factor and when you can calculate the new impact in global warming impact. And when this has to be included as, we have to use some tricks. It has to be included as a static value into the inventory, but you cannot provide a full profile with like the ones that Damien showed year by year. So we pre-calculated and then we put it in as an emission. That is also something we have been trying to explain in the, or we plan actually to explain in the tutorials, because it's an issue how to implement this in the software, because the software is not designed for that. Damien, go ahead. Sorry.
Yeah, softwares are designed for time invariant studies, so that makes a problem for accounting for time, the time dimension. So yeah, there are two possibilities. Either you, as Massimo said, you create your own impact assessment method with the CO2 at year 1, CO2 at year 12, and CO2 and methane at year X, and then you import it and you update your calculations in the software with this new kind of method. Or you can also, with the software, depending on the software, more or less easily export the inventory flows, uptakes, and emissions of each greenhouse gas, and then you can export it as a table in a spreadsheet and use the material in the repository to retrieve the relevant characterization factors and then do the calculation in spreadsheets. So yeah, two complementary possibilities, but yeah, indeed, it's not a one-click button solution, unfortunately.
In general, if I may have a more general comment about software, throughout the entire project, there's been a lot of dilemmas about software, because we can develop some tools, but then they are advanced, so you need to be good at software or use specific software. We also we don't have resources to develop tools for all types of software, right? So it was always like, okay, did you do this for this software? Did you do this for this other software? So we had to kind of prioritize where we could facilitate the use of specific tools or models within a specific software or not. And this has been different priorities for different parts of the project. Yeah. Thank you.
Yeah, so it turns out is indeed a very legitimate limitations of the technology right now.
Yes.
Yeah. Okay. Shall we try for the next question?
Yes. So the next question is, what strategies can ensure this method is both adopted and maintained? And of course, it's okay to take some time to think about it. Although I can see the responses coming in quite fast already. So thanks everybody who already responded.
Yeah, at least it looks that it works quite well, this poll asking questions. If you have any practical difficulty, you can also use the chat to ask this. But apparently it works reasonably well looking at the answers. You see as the number one answer is the automation of the practical implementation. And the second most popular one is the inclusion in standards. How would you do that? Automate the practical implementation I'm asking for speculation, Massimo and Damien. But maybe you can freely think about, would that be possible to automate the implementation of this methodology in a way that you don't have to be really a top scientist to do it.
Yes, I mean everything is possible, right? It's the question is whether it is possible in this project. To what extent? I think definitely should be possible. It's a matter of having enough interest in doing that and choosing where. I think there is already probably already some tools that could allow you to do this in an automated way. So to introduce this kind of analysis in existing software, as we have discussed before.
I would say,
Yeah.
I'm just also speculating a bit.
Yes.
I would assume that you would need to automate this. You would need to be able to define typical carbon emissions related to certain biomasses. So you can select the biomass, and you would need to automate certain use phases. That it is for this and this product group, we have a standard use phase or something. Yeah, because you have to make it easier, of course, for people.
Okay, in that way. No, I was thinking more like that you get your how to say, in a sort of model or application or software. You say, okay, I have this product, I have this time horizon, I have this emission at this time, and then the characterization factors are automatically calculated for these emissions with the right timing, and then they are integrated in the calculation so that you don't need to do it externally. So you work still in the same platform or software, and this is managed internally. That could be a way of automating this, right? And then you could have different choices. Okay, do you want to look into the global warming potential with 100 or 500? This is already kind of automated. Some of it, but you choose the impact assessment method that you want to have, right?
That would, I think, already be possible with some time and some attention.
Yes.
Yeah, that would be nice. Yeah, interesting.
There could be even simpler solutions that we could use, but that's something we can definitely consider for the end of the project.
Yeah,
we are always getting there, things applicable and as easy as possible. This is and the trade-off is always that the complex things are not super easy to do, right? So we have to kind of get the sweet spot between these two things. But I definitely understand the comment here, and I actually agree with that. But the more practical implementation means that those who develop these tools will have an interest in keeping them updated, because they use the more, and then this will in turn will also stimulate some continuous methodological development and maybe also inclusion in standards. So these things are related. Yeah.
When I think at the special aspect of inventories and impacts, well, 20 years ago it was very complicated to integrate spatial characterization, because it was not inside the structure of the databases, so not even less in the software. And then the spatial dimension entered, mostly because some processes like electricity is very location dependent. So there were some adjustments with the existing structures to to consider this spatial resolution. And then time after time, it became increasingly important, and then it became a full part of life cycle inventories. And every exchange is now specialized with more or less high resolution, but it's still the location factor is always here. We can see that for characterization factors and impact assessment methods, it's a bit behind, but it's following. And now most impact assessment methods that need spatial resolution are ready to be implemented. It's always a question of parallel advancement between software development and database development and needs by the practitioners and the regulations. So I'm quite optimistic that in the in coming decade, this time dimension will be much easier to implement. And we have to acknowledge that today it's more a manual thing to do.
Okay,
And
thank you. Thank you,
Yeah.
Damian, for this optimistic take on your work, which is good. Before we go to the next question, there's a question in the chat.
Yes.
It's a little bit confusing, but I'll try to read it up. Is it so that we are substituting the fossil-based products? In that case, it could be misleading, since there won't be fossil-based products in the future. Time dependency. On the other hand, if we are substituting biogenic-based products, then the harvesting stage could be 0. So, Massimo or Damien, can you make something out of this?
Yeah, I think I don't recall exactly the example that Damien has, what kind of byproduct was substitute, or what was the substitution there. But in general, here we're talking about substitution methods. So if you have a multifunctional activity and the byproducts or the dependent co-products are substituting functional equivalent products in the market, then the impact of this other product is subtracted from your account. And this happens whether it is fossil or bio-based. So the entire product system is substituted. And I don't think it's I like the comment that in the future you have to make some assumptions of what will be substituted in the future, right? That is correct. Nobody knows exactly the future, so we also have in our guide on sensitivity analysis, this is a place where you have to use your sensitivity analysis skills. Regarding the biogenic production, as in the example that Damien mentioned, you will substitute for the entire biogenic production, so this carbon uptake is not going to take place. So you will get a debit instead of a credit.
Maybe I can share the screen of the life cycle system with the different co-products. Hopefully it would help to answer the question. So we have 3 main co-products in the manufacturing stage, and also at the end of life, when the product can be valorized, we can have energy, heat, or material. In that case, ethanol would substitute biogenic ethanol, because in the present and the forecast shows that, well, ethanol is almost entirely produced out of biomass. So here is what Massimo was mentioning just earlier. So might be not that a good idea of producing ethanol with that side stream, and we need to consider other options because here we would be substituting some bio-based production with some other bio-based production. So we put a competition between 2 bio-based systems instead of getting so we get away from the main purpose of getting rid of fossil material. On the other side, we can see propylene and the resin from the oligomers of lignins, and these would substitute fully fossil material. So in that case, we would have there is carbon uptake in the growing of biomass, and then substitution from fossil stock. So here we have net benefit. And in the end of life, interestingly, the recycling part into other building material, boards, could be replaced substituting fiberboard or plasterboard. And yeah, of course, there is a difference because plasterboard is not biogenic, it's from minerals. So here in that case, the carbon taken up by the biomass growth would be still remaining within the final product after recycling. So good point, net benefit. But if that product would replace fiberboard, in that case, well, it's much more neutral effect, because we would replace bio-based product by another bio-based product. So yeah, these are some illustrations of yeah, let's be careful with these side streams in a bio-based economy. That's quite important to keep the goals in mind. I hope it helped answering.
Thank you for this elaborate answer, and also for the answer in the chat from Massimo. Great. Do we have one further question?
Then I will launch.
No, go ahead. Yes, Rachel. Thank you.
Like quite a simple question to see what type of guidance people prefer in applying the methodology. This is really practical for how to implement it.
We have, of course, already the guidance document on Zenodo, guidance documents, but we are always interested to learn how we can improve on this. Massimo, I believe that you will need.
I'm thinking that we didn't put the option of a TikTok video or anything like that. Dancing. I'm happy it was not on the list, because it could have been.
I'm not sure we have the resources
Yeah,
within Live to make these
I'm
TikTok videos.
rather the skills. The
I'm not
skills is
volunteering
an
anyway.
issue.
Yeah, but video training is a nice way, of course, of conveying information. You can, of course, have these. You have videos on LCAs where people share their screen and just walk people around methodologies, like, okay, how do you do this? How do you do that? And then they show it very clearly on videos. So
yeah, no, video training is good. I agree with the. I mostly agree with the answers of our audience today. I don't know what to say. It's a good reflective audience. No, video training is really good. It just takes a lot of time to do, but yeah, we have done also video trainings here at Tilburg University for our students. Many on various SCA topics. It's usually appreciated. Yes.
Yeah. The other interesting thing is that the option presentation webinar is 0%. we are now in a presentation that we
good. We haven't planned any more webinars, so
yeah.
Okay.
No, but I mean the video training you can watch all the time you want, so it's better. Yeah, it helps. You can take it to your own pace.
And the Excel tools are, of course, a good point, which is given in the chat. And I think also it wasn't the top 1 or 2, but using it in your own context, so in a way via a case study or similar, that is also seen as useful, and I can understand that. Okay. Shall we go to the next question?
Yes, I launched it, and I think since this is a word cloud, it might take some time for people to fill it in. So
uses of the methodology that we might have overlooked.
Yes, and if you want to see the result, you can click in the chat also on the responses on the More button, which we can see already somebody answered emission scopes. But I'm sure more reactions will follow.
Yeah, I think it's also a difficult question, of course. Yeah, what other uses there are? Yeah, because the main use to calculate the global warming potential is very clear. And the other use as well that requires indeed some thinking.
Yes, and we can also make this question more broader about other like aligned methodologies that we discussed. If it does not need to be only focused on the greenhouse gas emissions.
Yeah. But Damien, do you yourself see any other uses of your methodology for this global warming potential?
It's not my methodology. It's collective work.
Yeah, the technology you applied, of course. Yeah.
To some extent, it's still related to LCA, of course, and yeah, stepping beyond the commonly used tools.
Yeah, what I can think of is yeah, just when you can more accurately predict the global warming potentials, you can use that to monetize certain activities. Yeah, but that's maybe just an application of the results, not so much as an application of the methodology in itself. Could you also extend it to other emissions? Indeed, what people said.
Yeah.
Yes, other types of impacts.
Yeah.
Sure. Definitely, yes.
Wouldn't that require a lot of work in the sense that for carbon emissions, global warming, we know a little bit about how long it stays in the atmosphere and etc. etc. We have some idea about global carbon balances. For other emissions, we might also use that. Might also have to develop then more information on that.
Yes, we need to consider it category by category because all of them have different time horizons. Some of them are reversible and some others are not. Maybe resource stress on resources. That could be something interesting, both on non-renewable and also renewable resources. But it's always related to biomass. I'm thinking out loud.
Yeah.
Well, where a time dimension and the intensity of the impact, so the yearly impact and cumulated over typical critical periods, that would be criteria to identify which impact categories might be, could use a time dimension.
Okay.
Maybe we can look on the next question because it's also about what people see as the main value of incorporating it in the greenhouse gas emission calculations.
Okay.
And then after this, I think we should go to the questions about the general aligned methodologies.
Yeah, because otherwise we run out of time, of course.
Yes.
Yeah, let's do this question quickly. Yeah, it's quite clear that people say, well, it is a more accurate representation of environmental impacts. And it could help us in decision making in policy planning. Yeah. Yeah, we have a wonderful audience, I would say.
Yeah, it's good to hear this. Yeah.
Okay. Good. Any quick comments on this from others, or otherwise we can continue?
I don't have much to add. I think I agree with the answers. I mean,
yeah. Okay, let's continue.
Okay.
The part for the general methodologies. We've also here a few questions, and of course, as you can see, we are very interested in your answers, and we also use it as a trigger to discuss certain things, of course. What do you see as limitations of the aligned methodologies? And then we are talking about the methodologies as presented by Massimo in the first part of the workshop.
So we're all serious. Yeah.
It's nice to see the results going in so fast. We already have 10 responses now. And most votes is for that it's not applicable for certain standards.
Yep. I think we have said this before in other workshops, but it's very difficult to be applicable to all standards, whatever you do, because there are so many standards nowadays and they also contradict each other to a good extent. So whatever you do, you will be not compliant with one of them, at least. So yeah, I acknowledge this is an issue, but it's also something that we have a bit of difficulties in. We have tried as much as possible in this project to be standard neutral, let's say, or agnostic, to have a development of tools that in principle you can use across a series of sectors, across a series of cases, and across a series of standards as well. But of course, not everything is not a one-to-one match. So not everything we have made can be used in all standards, for sure. Yeah.
Yeah, I would also like to add to that standards are also not set in stone. Huh? They
exactly.
They should evolve based on changing insights, scientific insights, changing surroundings, changing perceptions on what we think is important. And we of course, that development needs to be fed by work like this. Huh?
Yes.
Yeah.
Good point.
It strikes me that the point of the data, not enough data, is not considered by too many people as a limitation. Because in other workshops, we often hear that when we present results from our case studies, we do that in sector-specific workshops for Aligned, then we often hear people say, well, I foresee a problem with getting enough data on applying these methodologies, especially when they go outside of the direct value chain, which often happens with the aligned methodologies. But here, not too many people. Can you say something, Damien, on the availability of data for the methods that you're using? Or maybe Massimo, you.
I'm not sure I get the question, because the data that we have been using come from the case studies. So some data we provide ourselves, for example, the characterization factors, or we provide rather tools than data, in fact. So it is true that we don't have much data. That is true, but it's also because it was not our purpose to have data. We have rather tools and methods to apply to your data.
No, that's right. But for example, if we talk about using a consequential approach, you need to have
okay, yeah.
mix, and you need to have data from outside of your primary value chain. And I know in the various case studies, people had some difficulty in getting that.
Like in the example of substitution we were talking about before.
Yeah.
Yes. But that could be perceived by some, but I didn't experience that myself. I think actually most of the times, unless it is a very prospective scenario that you're looking into a certain future not so close, like in the case Damien was mentioning, I think people are pretty industry people are pretty aware of which markets they are targeting for their products, what are competitive similar products that they are substituting. So I don't think there we have an issue. I mean, maybe the issue is explaining the methods a bit better, but I think once it's explained, my experience with industrial partners is that they know very well how to answer these questions. They know very well their markets. We have had some issues in the more prospective cases where, like, if you have multiple co-products and in the future you don't know exactly what market that you're targeting, but that's a problem of uncertainty in itself. It will be the same if you have to do allocation using prices. You also will have a problem to figure out what are going to be the prices in the future. So I think I don't entirely agree with this that data can be, the amount of data can be too much. I mean,
thank you.
Then there might be other examples. I don't know. Yeah.
Good. Then the next question: do you have recommendations to refine these methodologies for broader applicability? And it's quite clear that most people like to see that integrated into commercial LCA tools like CIMA Pro. Okay.
Yeah.
Yes, and I think then that this would be the final questions due to the time. So maybe if somebody else want to have more general a question or something to say, feel free to turn on your microphone or type it in the chat now. Otherwise, I think we can start to finalize the workshop.
Yeah.
Of course, there are a lot of feedback buttons in
Yes.
the Align website and on the Zenodo community repositories. So yeah.
I think
hopefully we will hear from you.
This is a good takeaway message. We very much appreciate the feedback from all of you during this workshop, but also when you use the method via Zenodo, there are easy ways to bring back the information. We hope, and we have tried to make it in such a way, the methodologies, that they can be used, and we want to improve that even. So yes, we hope you enjoyed this. I would like to thank Massimo and Damien for both their presentations. Thank you. I would like to thank Rachel for the excellent work on this. And I would like to thank all of you for your attention. And as I said, keep feeding us with the feedback. We appreciate it. We take it in and we think about it. The presentation will be put on the YouTube channel of Aligned, so that you can look at it later if you want. And for the rest, I think I would like to wish everybody a very good afternoon. Oh yeah, and we have an upcoming joint event on with our sister project, Calimero. That's a project which is doing roughly the same topic as we do, but on a different way. And we have decided we'd like to combine our efforts in a nice Science for Policy joint event. It is on June 4th in the morning, and it is very much about the policy implications of what we are doing. if you want to watch the live stream, you can register at the link which is put in the chat. And of course, you can find it on our website. So you are also very much invited to that event. There's a QR code, etc. So enough to do for that. Thank you all and have a very good afternoon.
Thank you so much.
Bye.
Thank you, Patrick, for organizing.
Thank you, everyone. Yeah, thank you, Patrick.
Bye-bye, everybody.
Bye.